I've seen posts all over that show a simple subtraction problem, 32 minus 12, solved the way it was traditionally taught versus the Common Core way. These posts complain about the complexity of Common Core, often accompanied by strong political rhetoric. So let's compare some subtraction methods. First, let's do a problem the right way, the easy way, the way you were taught and the way it should be. Here's the problem. You can't take 6 from 5, so you have to borrow, and 15 minus 6 is 9. You can't take 7 from the remaining 3, so you borrow again to get 13 minus 7, or 6. You can't take 8 from the remaining 2, so you borrow again to get 12 minus 8, or 4, and the 1 comes straight on down. That was easy. Now let's think about what you've done. You've pretty much shoved a bunch of numbers around by a method you learned by rote, and even if you were taught the underlying math, it's fairly well hidden. Here's another method, the European way, which is what my mom taught me. First, let's use it on a simple problem, 67 minus 24. The trick behind this method is upward addition. You don't subtract at all. So what plus 4 equals 7? 3. What plus 2 equals 6? 4. Now back to our original problem. I'm going to modify the question a bit. What plus 6 ends with a 5? Well, 6 plus 9 gives me 15 and I carry the 1, just like addition. 1 plus 7 is 8. 8 plus what ends in a 4? Well, 8 plus 6 gives 14, carry the 1. 1 plus 8 is 9, plus 4 gives 13, carry the 1, and 1 plus 1 is 2. 3 things to note about the European method. First, if you think about it a bit, it's really the same thing you do if you were checking the result from the way we did it before. Second, once you start using it, you might find it much faster than doing it the way you were taught originally. And third, it's still a lot of shoving numbers around without knowing the underlying math. Now, let's look at one Common Core way, not the Common Core way, because Common Core encourages teaching multiple methods so you can get different perspectives on how to solve problems. Here's the problem again. And this time, let's think about it as how far is it from 876 to 2345? Because mathematically, that's what subtraction is. It's the distance between numbers. If these were milepost markers, that would be a reasonable question to ask. How far is it from mile 876 to mile 2345? Well, 4 miles from now is mile 880, a nice round number. 20 miles further gives us mile 900, another nice round number. 100 miles from that is milepost 1000. 1,000 miles from that is milepost 2000, and then it's only 345 more miles to our destination. Add those numbers up and there's your answer. Now I can guess what some of you are thinking. That's stupid. It's much more work than doing it the right way. Nobody would ever use the Common Core way in real life. Really? If you buy $15.79 worth of groceries and hand the clerk a $20 bill, how much change should you get? Do you want the clerk to pull out a piece of paper and do it the right way? Not just no, hell no. You want the clerk to give you a penny to get to a nice round $15.80, then 2 dimes to move up to $16, and then 4 ones and you have the correct change for a total of $4.21. And the clerk used one of those stupid, much more work Common Core methods to do it. The takeaway from this video, and what Common Core is really saying, is that there's more than one way to solve problems. You should learn multiple methods so you can use the one that best fits the problem at hand, and you should always try to understand the math behind the method.